This is the state of Kerala in India. With beautiful backwater network all over the state, boats were the primary transport in Kerala until a few decades ago. But now water transport has come to a standstill due to the presence of these green floating plants that choke the waterways. Locally known as African Pola, they are an invasive species called water hyacinth. Water hyacinth or Iconia crassipes is one of the most invasive species of aquatic plants that is colonizing water bodies globally at an exponential rate. This led to Pola, a regenerative design method to create biomaterials from water hyacinth. Water hyacinth is native to South America but has now invaded over 50+ countries. Since this is a global problem, the solution involves a lot of hands. Water hyacinth plants were harvested from water, cleaned, roots removed, and dried under the sun. Water hyacinth stalks are bulbous and spongy and are up to 20 inches long. It has high cellulose content, the presence of hemicellulose and lignin as well. Its fibers are very strong and are traditionally used in basket making. To make biomaterials, the dried stalks were cut into small pieces to make pulp and powder. Several methods were tried out to create biomaterials. Cooking, casting, mold and decal, compression molding, even 3D printing. The ingredients ranged from common kitchen essentials like tapioca starch and eggshells, resin from trees, powerful natural plasticizers, seaweed harvested from the ocean, even bacterial cellulose. The first material made was an alternate leather using seaweed and plasticizers. Various iterations were tried out with different sized fibers, and adding other ingredients like charcoal and onion dye to get different colors and textures. They are heat resistant and waterproof. The thickness also varies. These materials are pliable and can be used to make products like bags. One material even resembles EVA form. All these materials can be cut using a laser machine. Other ways of biotechnologically making alt leather was tried out, using bacterial cellulose. Next, hard materials were made using natural resins from plants. Water hyacinth has a high absorption ability. This property led to the next material. Yes, cat litter. Next was thermoformed biocomposites. Thermocompression molding was used to activate the binding properties to create these beauties. Different sized fibers were combined with binders. An alternate to plywood that could be milled and another that could be laser cut was created. But just creating these materials is not enough. Local value and stakeholder maps need to be created across the globe. A distributed ecosystem of fabrication needs to be made. Pola has a long journey ahead.